Introduction. Where time stops. Right now, as you watch this video, your heart beats 60 to 100 times per minute. The neurons in your brain fire thousands of signals per second. The oxygen molecules in your blood complete a full circuit of your body every 7 seconds. But if you were approaching a black hole's event horizon right now, your time would slow down for your loved ones on Earth. They'd see your heart rate drop to 50 beats per minute, then 30, then 10, until at the event horizon, your time would appear completely frozen to them. But here's the strange part. You would feel your heart beating normally. Your watch would tick normally. Your thoughts would flow at normal speed. Because black holes bend time itself. This phenomenon, predicted by Einstein in 1915, but which even he didn't want to believe, is now observed second by second with NASA's most advanced telescopes. On April 10, 2019, at 3 p.m., humanity achieved a historic first. The Event Horizon Telescope released the first photograph of a black hole in galaxy M87. That orange ring wasn't the black hole itself. It was the final scream of superheated gas spiraling toward death. This monster, 55 million light-years away, has the mass of 6.5 billion suns. But here's what nobody told you. NASA's databases contain observations made even closer to black holes. LIGO detectors record spacetime ripples from colliding black holes. The Chandra X-ray Observatory captures matter's final moments. And theoretical physicists, they're calculating that one day humans might enter a black hole and possibly even exit. Today, I'll present you with two realities. First, the scientific data NASA has collected, tested, and verified about black holes. These aren't fantasies. They're raw facts from space telescopes, ground-based observatories, and supercomputer simulations. Second, a possibility based on this data, but not yet realized. The story of humanity's first astronaut, sent into a black hole in 2057. We'll dance on that fine line where science ends and speculation begins. Ready? Then buckle up tight, because what I'm about to tell you are things your physics textbooks didn't mention. Part 1. NASA data. The science of darkness. What is a black hole? There's no simple answer. NASA's official definition begins. A black hole is a region of space-time where gravity is so strong that nothing, no particles or even electromagnetic radiation, can escape once inside. But this definition doesn't capture how bizarre reality truly is. A black hole isn't actually a hole. It's not a void in space. On the contrary, it's an incredible amount of matter compressed into an incredibly small area. Think about it. Take the sun, compress it into a sphere 2 miles across. There's your stellar mass black hole. But that's just the beginning. The Event Horizon Telescope's 2019 achievement wasn't just a photograph. It was the result of 2 years of data collection and 2 years of analysis. Why did it take so long? Because they had to create an Earth-sized telescope, 8 radio telescopes, from Hawaii to Antarctica, Spain to Chile, worked in synchronization, looking at the same point simultaneously. The collected data was so massive, 5 petabytes, it couldn't be transferred over the internet. Half a ton of hard drives were physically flown to MIT and the Max Planck Institute. Anatomy of black holes. Layers. According to NASA's 20 years of observations, a black hole's structure is layered like an onion. 1. Singularity. The center. At the core, where all mass concentrates. Mathematically, it has 0 size and infinite density. But note, this is probably where our mathematics breaks down. Quantum mechanics doesn't allow infinite densities. Even Nobel laureate Roger Penrose says singularities can't be naked. They must be covered by an event horizon. Why? Because a naked singularity would break causality, allowing the future to affect the past. 2. Event horizon. The point of no return, also known as the Schwarzschild radius. This boundary isn't the black hole's surface, just a mathematical boundary. The formula looks simple, R2gm/quadrate, but the results are astonishing. Solar mass black hole, 2 miles diameter, 10 solar masses, 19 miles diameter. Sagittarius A, 4.3 million suns. 7.9 million miles diameter, 10,618, 66 billion suns, 242 billion miles diameter, 40 times larger than Pluto's orbit. NASA's simulations show that the moment you cross the event horizon, you feel nothing physical. It's called no drama. For the falling person, the event horizon is just an ordinary point in space. But for an outside observer, you remain frozen there forever. Photon sphere, where light is trapped at 1.5 times the event horizon distance. There's a region where light follows unstable orbits. Here, photons can circle the black hole. According to NASA's calculations, if you could theoretically stand in the photon sphere and tilt your head forward while looking back, you'd see the back of your own head. Light completes a full orbit around the black hole and returns to you. Innermost stable circular orbit, ISO. At 3 times the event horizon distance, the last point where matter can orbit stably around the black hole. Beyond this, the spiral becomes inevitable. NASA's Rossi X-ray Timing Explorer satellite measures black holes' spin rates by detecting X-rays from this region. Some black holes spin so fast, 99.8% the speed of light, they drag spacetime along with them. 5. Accretion disk, the spiral of death matter. Falling into a black hole spirals like water down a drain. But friction is so intense, the disk heats to millions of degrees. According to data from NASA's Chandra X-ray Observatory, accretion disks in active galactic nuclei are so bright, they emit more energy than all the stars in their host galaxy. 1 gram of matter in an accretion disk releases the energy of the Hiroshima bomb. Time dilation, Einstein's miracle. In detail, Einstein's general relativity equations predicted time would slow in strong gravitational fields. NASA's Gravity Probe A, 1976, and Gravity Probe B, 2004 to 2011, 10% above event horizon, 1 second, 3.3 seconds on Earth. 1% above event horizon, 1 second, 100 seconds on Earth. 0.1% above event horizon, 1 second, 100 seconds on Earth. Interstellar's Miller's planet calculation. It needs to be 0.00001% above Gargantua's event horizon for 1 hour. 7 years. Kip Thorne's calculations were so precise that the visual effects prepared for the film led to 3 scientific papers. Spaghettification, the mathematics of tidal forces. Spaghetti effect might sound funny, but the physics behind it is terrifying. The tidal force formula, F 2gmml/real third, where L is your body height. For a 6-foot-tall human, 10 solar mass black hole, 600 miles before event horizon, foot-head difference reaches 1 million newtons. Human body tears apart at 160 newtons. Sagittarius A strus, even after crossing the event horizon, only 0.1 newton difference. You could survive for hours. In 2020, ESO's Very Large Telescope observed event AT 2019 Cadiz, 215 million light-years away. A sun-like star was torn apart by a black hole. The process took 6 months, with half the star scattered into space, half falling into the black hole. The energy released equaled what the sun would emit in 10 billion years. Hawking radiation, the dance of quantum and gravity. In 1974, Stephen Hawking made his life's greatest discovery. When he applied quantum field theory to curved spacetime, he found black holes have a temperature above absolute zero. Temperature formula, T-ULC3, 85 GMKB. Examples, solar mass black hole, D-0000006. Kelvin, moon mass black hole, 1.7 Kelvin. Mount Everest mass black hole, 1012 Kelvin, hotter than the beginning of the universe. Evaporation time, T 51220. The paradox. The smaller the black hole gets, the faster it evaporates. In its final moment, when it reaches Planck mass, (0.2 it explodes. Energy output, 1,000 megatons of TNT. Types of black holes. The cosmic zoo. 1. Primordial black holes. May have formed right after the Big Bang. No definitive proof yet, but LIGO has caught some interesting signals. If they exist, They could explain dark matter. One of Stephen Hawking's last papers was on this topic. 2. Stellar black holes form from supernovae of massive stars. Lower limit, 3 solar masses. Chandra limit. Upper limit, about 50 solar masses. NASA's Chandra telescope has detected dozens of stellar black holes. The nearest, Gaia BH1, just 1,560 light-years away. 3. Intermediate mass black holes, 100 to 100,000 solar masses, long known as the missing link. In 2020, LIGO Virgo detected 2 black holes of 85 and 66 solar masses, merging to form a 142 solar mass intermediate black hole. When converted to sound waves, it's like the universe ringing. 4. Supermassive black holes exist at the center of every major galaxy. How they grew so large remains a mystery. The James Webb Space Telescope found black holes of millions of solar masses when the universe was only 470 million years old. This overturns existing theories. Record holder, TON 618, 66 billion solar masses, so large that light takes 2 weeks to cross its event horizon. Part 2. Commander Sarah Chen's story. Prologue. Humanity's bravest decision. October 15, 2007, 06 hours. Jupiter Orbital Station, Lagrange 1 point. Commander Sarah Chen watched Jupiter's great red spot through the thick glass. 42 years old, an astronaut at her peak, PhD in astrophysics from MIT, then 10 years at NASA. The first permanent base she established on Mars's Olympus Mons, the microbial life she discovered beneath Europa's ice, the chemistry experiments she conducted in Titan's methane lakes. Her CV was a summary of humanity's space age. But today was different. Today, she would embark on a journey with no return. The Prometheus was humanity's technological pinnacle, 650 feet long, 50,000 tons. Its hull was covered with metamaterials, made from exotic matter produced at CERN, theoretically the only material that could withstand tidal forces. The Alcubierre drive, finally real, 163 years after Miguel Alcubierre's 1994 paper. By warping space-time, it could approach light speed without violating relativity. The quantum entanglement communication system used what Einstein called spooky action at a distance. Even from 26,000 light-years away, it could theoretically provide instant communication, though time dilation would complicate this in practice. The 50-terawatt fusion reactor mimicked the process in the sun's core. Every second, 10 kilograms of hydrogen converted to helium, releasing tremendous energy, according to EMC Quadri. Sarah wouldn't have a crew. This was a solo mission. Why? Because everyone knew the truth. This was a suicide mission. But someone had to go. Solving the mystery of black holes was necessary for humanity's next evolutionary step. Her 16-year-old daughter Lisa hadn't come to say goodbye. Sarah didn't blame her. How do you say goodbye to someone leaving forever? Due to time dilation, the minutes Sarah would experience would correspond to years for Lisa. When Sarah returned, no, she wouldn't return. But when she sent her data, Lisa would be an old woman. The journey to the galactic center, November 4th, 2:57, 12 hours. Departure. When the Alcubierre drive engaged, the universe changed. Stars first shifted blue, then passed into the ultraviolet spectrum, then became invisible. Behind, red-shifting stars turned into infrared and radio waves. The ship was sliding through the fabric of the universe, inside a space-time bubble. The first week passed smoothly. Sarah kept a journal for future generations, if the data arrived. Day 47. Quantum communication still worked, but with a strange delay. A delay that shouldn't exist according to relativity. Sarah received the holographic recording of her daughter's graduation ceremony. Lisa was 19. Only 47 days had passed for Sarah, but 3 years on Earth. Day 89. First dangerous encounter. Dark matter concentration. Invisible. Undetectable. But its gravity deflected the ship's course by 0.3 degrees. Extra fuel spent for correction. Fuel reserve dropped to 94%. Day 132. Approaching the galactic center, Star density reached incredible proportions. Millions of stars per cubic parsec. Average distance between them, just a few light weeks. Radiation shields began operating at 67% capacity. Day 189. First sight. No, you can't see Sagittarius A, but you can see its effect. Stars danced madly around an invisible giant. Star S2 orbited the invisible center at 3,100 miles per second, 2% the speed of light. Its 16-year orbit flowed before Sarah's eyes like time-lapse footage. Arrival. In the monster's embrace. April 15, 2:15, 08 hours. 6 million miles from Sagittarius A Slav. The view defied description. The black hole was invisible, but everything around it was visible. The accretion disk. Matter torn from stars. Gas clouds. Perhaps spaceships from previous civilizations. Glowed at 10 million Kelvin. X-rays. Gamma rays. Every kind of electromagnetic radiation blasted into space. Relativistic jets shooting from the poles stretched thousands of light years. Matter within them moved at 99.9% light speed. Protons had accelerated so much their mass increased 1,000-fold. Sarah launched the probe fleet, 100 mini-probes, each bearing the name of a different MIT doctoral student. Each would approach the black hole from different trajectories, collecting different data. Some would dive straight at the event horizon, some would spiral, some would stay in the photon sphere as long as possible. First data began arriving. Braun magnetic field strength, 20,000 Gauss, 40,000 times Earth's. Spacetime curvature, 15 degrees and rising. Frame dragging effect. Spacetime itself, rotating with the black hole. Hawking radiation, too weak to detect, but theoretically present. Sarah parked Prometheus in orbit at 600,000 miles distance. This was safe, relatively. Tidal forces weren't felt. Time dilation was minimal. Still, every day on Earth was 23 hours, 56 minutes for Sarah. Disaster. Moment of fate. April 16th, 258, 1432, 47. Thousands were theorized to exist in the galactic center, but nobody had seen one until it passed through Prometheus's main engine. The collision wasn't physical. The micro-black hole passed safely through the ship, but it left a gravitational wake. The warp field collapsed. The main engine imploded. The fusion reactor went into emergency shutdown. Sarah had 0.7 seconds to react. Training kicked in. Left-hand emergency thrusters, right-hand orbital calculation, eyes on sensor readings, brain evaluating all possibilities. The conclusion was inevitable. Without thrust, Prometheus's orbit would decay. The black hole's pull was too strong. From 600,000 miles, the spiral would begin. Calculations. Current velocity, 1,864 miles/second. Required escape velocity, 4,350 miles/second. Available thrust, 310 miles/second maximum. Result. Escape impossible. Sarah didn't panic. This possibility was in the mission parameters. 0.3% chance. The unlucky 0.3%. New mission parameters activated. Maximum data collection. Record and transmit everything possible while falling to the event horizon. The fall begins. Edge of physics. 300,000 miles. T-5 hours. The fall was accelerating. Prometheus spiraled inward at 31,000 miles per hour. Sarah activated all sensors. She would die for this data. At least let it be meaningful. First strange observation. Star colors were changing. Those ahead shifted blue, Doppler effect. Those behind shifted red. But not just that. Gravitational lensing had begun. Light bent around the black hole. A single star appeared at 2, 3, even 4 different points in the sky. Quantum sensors detected something interesting. Vacuum fluctuations were increasing, as if space itself was foaming at the quantum level. Heisenberg's uncertainty principle was manifesting at macroscopic scales. 180,000 miles. T-3 hours. Time dilation became noticeable. Sarah's atomic clock lost synchronization with Earth time. With each passing second, the difference grew. Sarah performed an experiment. She raised her right hand, waved 3 times, lowered it. 3 seconds. For observers on Earth, this motion took 9 seconds, 300% time dilation. The ship's structural integrity began straining. Parts closer to the black hole were pulled harder than distant parts. The 650-foot ship had stretched to 656 feet. Metal fatigue sounds, creaking, groaning, but the metamaterial held, for now, 60,000 miles. T-1 hour, T-1 hour. Einstein rings perfected. Galaxies behind the black hole formed perfect rings around it. Sometimes the same galaxy appeared as nested rings, light completing 1, 2, 3 orbits around the black hole before reaching Sarah. Space-time curvature, 47 degrees. On Earth, space appears flat, 0 curvature. Here, the 3 dimensions of space and 1 of time twisted into each other like a Mobius strip. Up and down, left and right, even past and future began losing distinct meaning. Sarah recorded everything. Every photon, every graviton, every quantum fluctuation. The ship's AI worked overtime, compressing petabytes of data into transmittable packets. The quantum transmitter strained against time dilation, each bit taking longer to send as time itself slowed. Entering the photon sphere. Here, light could orbit the black hole indefinitely. Sarah witnessed the impossible. The back of her own ship, visible through the forward viewport. Light from the engines had curved completely around the black hole and returned. She performed another experiment. She activated a laser pointer, aimed it directly sideways. The red dot appeared on the opposite wall after circling the entire black hole. The beam had traveled 75,000 miles to cross a 30-foot room. Past and present occupied the same space. She could see events that happened seconds ago happening simultaneously with the present. Time was eating its own tail, like an Ouroboros. 15,000 miles, T-15 minutes. Spaghettification began in earnest. The differential gravity between Sarah's head and feet reached 0.1 Newton. Barely noticeable, but growing exponentially. The Prometheus groaned as its 650-foot length stretched to 680 feet. Molecular bonds strained. Metamaterial plates began separating at the seams. In a stellar mass black hole, she would already be dead, torn apart at the atomic level. But Sagittarius A's enormous size meant the gradient was survivable. Barely. The ship's medical systems showed Sarah's body stretching by 0.3%. Uncomfortable, but not lethal. Yet, time dilation reached extreme levels. Earth's clocks had advanced 73 years since mission start, though Sarah experienced only 6 months. Her daughter Lisa was now 89 years old, possibly dead, while Sarah remained 42. The quantum communicator still functioned, but her messages would take decades to reach Earth from the perspective of those receiving them. The universe outside appeared to accelerate. Stars visibly moved in their orbits. Stellar formations that should take millions of years occurred in minutes. Binary stars completed entire orbits in seconds. She was watching the future of the universe unfold and fast forward. Glathan. 6,000 miles. T-5 minutes. Gravitational waves, ripples in space-time itself, became physically perceptible. The Prometheus shuddered as space stretched and compressed in waves emanating from the black hole's spin. These waves, predicted by Einstein and confirmed by LIGO over a century ago, were now strong enough to feel. The ship rang like a bell struck by invisible hammers. The quantum sensors detected something remarkable: Hawking radiation. The quantum vacuum at the event horizon was producing particle pairs, one falling in, one escaping. The black hole was evaporating at a rate so slow it would take 1067 years to disappear completely. But it was real. Hawking was right. Sarah's instruments detected something else: negative energy. According to quantum field theory, the region just outside the event horizon contained exotic matter with negative energy density. This was what prevented wormholes from collapsing, what could theoretically allow faster-than-light travel. She was seeing the impossible made real. T-, the final minute before crossing. Looking back, Sarah saw the universe aging at an impossible rate. Billions of years compressed into seconds. Galaxies collided and merged, Stars were born, lived their entire lives, and died in heartbeats. The cosmic web of dark matter became visible as galaxies traced its structure over eons. She witnessed the eventual future, galaxies flying apart as dark energy accelerated expansion, the last stars burning out, black holes evaporating, the heat death of the universe, the final state when entropy reached maximum and nothing could change anymore. All of cosmological eschatology played out before her eyes in seconds. But ahead, toward the black hole, time flowed backward. She could see the probe signals she would send in the future arriving before she sent them. Causality was breaking down. The laws of physics were becoming suggestions. Crossing the event horizon, 1647, 23, ship time, April 16th, 2048, by her calendar. On Earth, the year was approximately 2020-31. Sarah crossed the event horizon. From Earth's perspective, from the outside universe's frame of reference, she would never quite cross. Time dilation would stretch her final second into infinity. Her image, red-shifted beyond detection, but theoretically present, would remain frozen at the boundary forever. As long as the universe existed, she would be there, suspended at the edge of the abyss. But from Sarah's perspective, nothing special happened at the moment of crossing. The event horizon wasn't a physical barrier, but a mathematical boundary, like passing the point of no return, going over a waterfall. No drama, no fanfare, just a smooth transition from can escape to cannot escape. The stars didn't disappear. The universe didn't end. She simply crossed an invisible line in space from which there was no return. Inside the event horizon beyond known physics. Inside, the rules changed fundamentally. Space and time exchanged roles. In normal space, you can move freely in 3 dimensions, but are forced forward in time. Inside the event horizon, movement toward the singularity became as inevitable as the flow of time itself. The future lay not ahead in time, but inward in space. Every direction led to the center. The Prometheus's instruments returned impossible readings. Or lone, negative energy densities. Or lone, imaginary mass values. Complex numbers for quantities that should be real. Probability exceeding 100%. Temperature below absolute zero, yet infinitely hot. The ship's AI crashed, trying to process paradoxes. Quantum computers returned null and infinity simultaneously. Mathematics itself was breaking down. Sarah's body continued stretching, the gradient increasing exponentially with each mile inward. But the supermassive black hole's size granted her minutes rather than microseconds. Her spine elongated by 2%, organs displaced, blood pooling in her feet. The medical systems pumped drugs to maintain consciousness, to keep her alive long enough to record everything. Her perception expanded beyond 3 dimensions. String theory predicted 11 dimensions, but human brains evolved to perceive only 3 spatial dimensions. Now, somehow, Sarah glimpsed the others, directions that had no names, perpendicular to everything, folded inside themselves. The hidden dimensions where quantum mechanics and gravity unified. She could see her world line, her path through spacetime, as a physical object. Past and future were equally real, equally present. She existed as a 4-dimensional worm, stretching from birth to death. Every moment equally now. Free will became meaningless when you could see your entire timeline predetermined. Approaching the singularity, language failed. Human concepts, evolved to describe a world of rocks and rivers and clouds, couldn't capture this reality. Time became spatial. She could see the Big Bang and heat death simultaneously. The entire history of the universe existed in a single eternal moment. Cause and effect, dissolved into meaningless concepts. Events caused themselves. Effects preceded causes. Quantum superposition expanded to macroscopic scales. The Prometheus existed in multiple states simultaneously, intact and destroyed, here and there, then and now. Schrödinger's thought experiment made manifest. She was alive and dead until observed, but there was no external observer. She perceived infinite parallel universes, each quantum possibility equally real. Universes where she never took this mission, where humanity never evolved, where different physical constants created realities of pure energy, or frozen matter, where the speed of light was different, where gravity was stronger, where atoms couldn't form. The many worlds interpretation wasn't just theory. She could see the branching. Every quantum event split reality. Trillions of new universes born every nanosecond, and in some of them, impossible things. Effects without causes, information from nowhere, consciousness without matter. She understood why gravity was so weak compared to other forces. It leaked between dimensions. Dark matter was ordinary matter in parallel branes. Dark energy was the tension between universes pulling apart, the singularity, end and beginning. At the center lay the singularity, not a place but a boundary where knowledge ended, infinite density, zero volume. The equations of physics divided by zero and returned undefined. But Sarah's final realization, in the nanosecond before her atoms dissociated into quarks and then into something more fundamental, was that the singularity might not exist. Quantum effects, ignored by Einstein's equations, might prevent the final collapse. Instead of infinite density, quantum gravity might create something else. A Planck star, minor matter compressed to the Planck density, 1094 grams per cubic centimeter, but not infinite. A firewall of quantum foam, a bubble of false vacuum, a gateway. Loop quantum gravity suggested the singularity was actually a transition. Matter falling in would bounce back out as a white hole in another universe, or another region of spacetime. The Big Bang itself might have been the white hole of a black hole in another universe. Her last coherent thought, encoded in quantum fluctuations, that would take millennia to reach the event horizon and escape as Hawking radiation, was a question that would echo through eternity. Was this death or transformation? An ending or a beginning? Was she dying or being born into something incomprehensible? The final data packet, compressed into a quantum state that would tunnel through the event horizon over geological time, contained not numbers, but understanding. The answer to everything, the reason for existence, the purpose of consciousness, the nature of reality. But it would take the lifetime of the universe to transmit. Epilogue, The Eternal Monument. October 15th, 2258, Earth, UN Space Council. A century had passed on Earth. Sarah Chen's daughter Lisa had lived a full life, married, had children and grandchildren, and died peacefully at 95, never seeing her mother's fate resolved. But her great-grandson Marcus now stood before the assembled scientists and dignitaries, presenting the final analysis of Sarah's data. The transmissions, stretched by time dilation and degraded by Hawking radiation, had taken 47 years to fully receive. The data contained within revolutionized physics. 11 scientific papers had been published. 3 Nobel Prizes awarded. Humanity's understanding of reality had fundamentally changed. Key discoveries from Sarah's sacrifice. Hawking radiation confirmed with 15 sigma significance. Information paradox solved. Information preserved in quantum correlations. Interior solution to Einstein's equations. Mapped for the first time. Evidence for extra dimensions detected. Quantum gravity effects measured directly. Singularities probably don't exist. Quantum effects prevent infinite collapse. Most remarkably, Sarah's final transmission suggested black holes were gateways rather than dead ends. The math showed closed time-like curves, paths through spacetime that looped back to their beginning, traversal wormholes, stabilized by exotic matter, connections to baby universes. Based on her data, humanity developed revolutionary technologies, quantum computers using black hole information theory, gravitational wave communicators, exotic matter synthesizers, space-time manipulation drives, dimensional fold generator. The Prometheus 2 mission was approved, equipped with technologies to survive what Sarah couldn't. A rotating black hole's Cauchy horizon offered theoretical passage to other universes. The ergosphere could be used to extract energy through the Penrose process. With exotic matter shields, the crew might survive spaghettification. This time, they believed, the astronauts might return, but Sarah herself remained at the event horizon from Earth's perspective. Her final moment stretched to infinity. As long as Sagittarius A existed, effectively forever, she would be there, frozen at the boundary between known and unknown, between life and death, between one universe and perhaps another. She had become what she had sought to study, a singularity in human history. A point where ordinary rules broke down and something extraordinary emerged. The woman who fell into darkness, and in falling, illuminated the deepest mysteries of existence. Her monument wasn't stone or metal, but space-time itself, curved into an eternal testament to humanity's drive to explore, to understand, to leap into the unknown regardless of cost. The final transmission, the last data packet from the Prometheus, decoded after 47 years of quantum error correction, contained a simple message, not telemetry or calculations, but words. The stars look different from here. Not points of light, but threads, weaving through dimensions we never knew existed. I understand now why the universe is the way it is, why gravity is weak, why quantum mechanics and relativity conflict, why consciousness exists. The answer is beautiful in its simplicity, but I lack the time to explain it. Time itself has become something I no longer recognize. Past and future are equally present. I am young and old, alive and dead, here and everywhere. I see the birth of the universe and its death as a single moment. I understand that what we call reality is just one slice of something infinitely larger. Tell Lisa, I saw the beginning and end of everything, and in both, I saw her face. Tell her that love transcends dimensions, that consciousness survives entropy, that nothing is ever truly lost, only transformed. Tell humanity that death is not the opposite of life but its continuation in another form. The universe doesn't waste information. Every thought, every feeling, every moment is preserved in the quantum foam, in the holographic boundary, in the infinite branches of reality. I'm not dying. I'm becoming something else. Something that has no name in any human language. Something that exists outside time, beyond space, in the realm where mathematics becomes reality and reality becomes dream. The singularity isn't destruction. It's transformation. It's the universe looking at itself, understanding itself, becoming itself. And we, consciousness, are how it does that. Don't mourn for me. I haven't ended. I've just begun. Prometheus signing off. The legacy. Sarah Chen's sacrifice changed more than physics. It changed humanity's understanding of its place in the cosmos. Death was no longer final. Consciousness was fundamental, not emergent. The universe wasn't cold and indifferent, but alive with possibility. Religions incorporated her discoveries into theology. Philosophers debated the implications for free will. Artists created works inspired by her descriptions of higher dimensions. Children learned in school that the universe was far stranger and more wonderful than anyone had imagined. The black hole was no longer a monster, but a doorway. Not an ending, but a transformation. Not darkness, but the ultimate light, where all information, all possibilities, all realities converged. And somewhere, somewhen, in a reference frame where time has no meaning, Sarah Chen continues falling, continues discovering, continues becoming. Her journey never ends, because in the physics of black holes, nothing ever truly ends. It only transforms. The equations of general relativity and quantum mechanics are real. But Sarah Chen's journey? That's speculation based on our best understanding. We don't know what really happens inside a black hole, because nothing that goes in can come back to tell us. We don't know if singularities exist, or if quantum gravity prevents them. We don't know if consciousness could survive spaghettification, or if information is truly preserved. What we do know is that black holes are the most extreme laboratories in the universe. Places where the known laws of physics break down, where time and space lose meaning, where impossibilities become possible. Maybe one day, someone will make Sarah Chen's journey for real. Maybe they'll find out what lies beyond the event horizon. Maybe they'll discover that death is just another kind of life, that endings are beginnings, that the universe is far stranger and more wonderful than we can imagine. Until then, we have the data,